When Mrs. Jones turns on her kitchen tap for the first time in the morning, she starts a flow of water into the house, which with brief intervals continues all day. She can see and control the water coming in. But where does it all go when it leaves the house? Where does the washing up water go when the bowl is emptied? The amount of water it takes in a week to keep one small boy's hands clean would probably float a battleship, and it seems that the bath is hardly empty before someone's filling it again. Where does all the water go when it swirls around and disappears? Soap and water rub out mud and dirt from clothes. The clothes become clean, but the water is often left very dirty. Down it goes through the convenient hole in the sink. But where does it go? It's a simple thing to throw away the dirty water from cleaning floors, or to pull the lavatory chain and see the water cascading down. But where are the waters rushing? Before the development of modern drainage during the past century, sanitation was primitive. Today it's taken for granted. The Jones family and all the people who live in their street can empty their sinks as simply and easily as they switch on the electric light. The maintenance of public health depends upon the efficient removal of this sewage, not only from houses, but from all the public lavatories, shops and hospitals in the community. The washing up that goes on in the house is magnified to huge proportions in places such as multiple dairies. Just as Mrs. Jones's washing up water goes down the sink, so the water that washed 10,000 bottles goes down the dairy drain. And so it is with industry in general. Trade waste presents a stern problem for the public authority in charge of main drainage, for some of it is harmful and dangerous. From breweries, engineering works, chemical and dyeing works, the waste from the various industrial processes runs away down the factory drain. These flows from factories are larger than those from houses, but they all find their way into the same sewers. When any building is erected, whether to live in or to work in, drains are laid leading to the sewer under the road. Some sewers lie near the surface. Others are very deep in the earth. They run across country and under city streets, man-made rivers in tunnels of brick and concrete. Small local sewers flow into larger ones, and the wastewaters of a whole district move as tributaries towards one great stream. As in natural rivers, the streams vary in appearance and rate of flow. At times of great activity, the sewage runs deeper and dirtier. On Mondays, there is the soapy evidence of wash day. From the first small drain down to sewers larger than a tube railway, like this one, the unwanted wastes of the world above the street are carried safely away. The very existence of modern cities depends upon drainage. After the first, and areas that were largely rural became industrial and residential. In the county of Middlesex, the local authorities were faced with many problems. It became increasingly difficult to provide proper drainage facilities for the ever-growing population. This is what happened to West Middlesex. Occupying 2/3 of the county, it contains within itself no less than 15 local authorities. The population in the area more than doubled in 15 years. In earlier times, local sewers had been connected to 28 separate sewage works operated by the local authorities. But because of the swift growth of population, new methods had to be adopted, and the Middlesex County Council became responsible for the drainage of the whole area. This county constructed 70 miles of main trunk sewers to join up with one large new works, and the 28 old works were then closed down. And now, when Mrs. Jones, who lives in Ruislip on the northern boundary, throws away her washing up water, she starts a flow that continues nearly 20 miles until it reaches Mogden. And from all over West Middlesex, from an area of 160 square miles, with a population of about 1,25 million, the sewage comes flowing in to be purified at Mogden. Mogden, one of the largest and most modern purification works in the world, was completed in 1936. The average flow treated is over 60 million gallons per day. In wet weather, the works could take 600 million gallons in one day, a volume that would flood Hyde Park to a depth of 5 feet. Sewers lie at different levels according to the contours of the land under which they run. One stream of sewage arrives at Mogden 60 feet below the ground. From the deep sewers, the flow arrives here and has to be lifted to the surface by pumps. It joins another large stream arriving at surface level, and both pass forward to the screen house. Here, rags and other large refuse which might choke the plant are sifted by screens. The electrically operated rake lifts the refuse to the top of the bars. Brushes sweep it onto a conveyor belt, which carries it into a machine where it's chopped into small pieces and passed back again into the sewage. The flow then moves on to grit chambers, where the speed of travel is reduced. This causes the sand and grit in the sewage to settle on the bottom in a fairly clean condition. The grit is removed from underwater by suction through a pipe travelling along the bottom, and is transferred to channels like this. 60 million gallons a day. The sewage from a population of well over 1 million people now flows on for treatment. Here, the first sample is collected for making chemical tests. This is necessary to ascertain the amount of impurity present in the sewage, and for the purpose of keeping a close watch on waste products discharged from factories. In wet weather, the flow into Mogden increases in volume, but the works are constructed to deal with these heavy storms. Most of the rainwater that falls in streets in this area is carried away by surface water drains, straight into streams and rivers. But some of the more dirty rainwater is taken into the same sewers as ordinary sewage, and arrives here. The normal flow moves along the first channel. After heavy storms, excess water flows over the weir and is bypassed through this other channel for treatment in stormwater tanks. These stretch away for a quarter of a mile. The normal flow moves through culverts to other tanks known as sedimentation tanks. Here the sewage passes through very quietly, and just as mud settles on the bed of a river, so solid matter settles down on the bottom of the tank in the form of sludge. This sludge is removed underwater by the machine. With an empty tank you can see what happens. The machine revolves slowly and scrapes the sludge at the bottom in towards a central well, from which it's pumped away for disposal. The heavier solids are taken out in this first process, and now the water's passed forward into larger tanks, where the lighter solids slowly sink to the bottom. To be a gentle and leisurely process, and the machine which scrapes the bottom hardly ruffles the surface. The large blade is lowered through the water and draws the settled sludge into hoppers at the end of the tank, and the sludge is pumped away. These two stages of sedimentation remove rather less than half of the impurities from the sewage. Samples taken at this point show a liquid that is still turbid and dirty looking. Before the water can be discharged into the river without causing a nuisance, it must be made much more clear and pure. To complete the purification, wonderful assistance is given by minute organisms, bacteria. The bacteria used are similar to those found in good garden soil. Many years ago, sewage was purified on farms like this one, where it was distributed over large areas of land. But thousands of acres were often turned into unsightly, bad-smelling marsh. Science and research brought improvements, and by about the year 1900, filter beds had been developed. In these beds, conditions are provided where friendly bacteria can thrive and make use of oxygen from the air to purify the sewage. This scientific principle is behind the activated sludge process, developed in more recent years. It was found that if sewage was agitated by air in a tank, the right kind of bacteria could be developed and utilized to do this work without the need of a filter bed. In this way, at Mogden, millions of gallons of sewage are treated in a very small space. Into the sewage is discharged a quantity of specially prepared activated sludge. Here's a small sample. A thimbleful contains thousands of millions of the living organisms. In this mixing channel, this activated sludge is pumped into the sewage. The mixture then passes through channels, and it travels about 1/3 of a mile in 8 hours, or about a yard a minute. During its journey, the mixture is continually aerated by small bubbles of compressed air, diffused from the bottom of the channels 12 feet below the surface. When the bacteria have completed their work, the mixture flows into final tanks, where the activated sludge itself is separated from the purified sewage. In contrast to the wilderness of many old sewage farms, this plant is more like an ornamental garden. The activated sludge settles readily in these tanks and is continuously moved underwater towards the center by a machine. The empty tank shows you how this is arranged. The sludge is discharged from the bottom and can be used again to purify more sewage. The purified effluent flows over the weir around the top of the tank. More samples are taken at this stage. Nothing is left to chance. This final effluent is clear and sparkling. Samples at various points are taken throughout the day and night, and some 200 are assembled for averages to be taken. Look at the difference between those 3 bottles. These average samples are sent to the laboratory, where a large number of tests are made and recorded. For one of these tests, a sample is placed in an incubator at a temperature of 80 degrees Fahrenheit. It stays here for 1 week and is then tested again. The effluent, now practically pure water, is ready to flow into the River Thames. The dangerous sewage has been cleansed at Mogden into a tributary of fresh, clear water. So clear that fish, which had been scarce before 1936, now fill the river, and the banks abound with happy fishermen. Nothing is spoiled in the vicinity of the outlets. All the recreations and pleasures of this lovely river are carried on within a stone's throw of the conduits through which the final effluent flows. But the work at Mogden is still only half finished. The impurities left behind in the form of a dark liquid sludge must be treated to make them harmless. The sludge is first pumped into covered tanks, where it's fermented at a temperature of 80 degrees Fahrenheit. Let's go into the laboratory and see what this process looks like. In this vessel, digesting sludge is heated by water circulating through the metal coil. The fermentation is brought about by bacteria, quite a different kind from those used to purify the sewage. During the process, gas is given off and is collected. The gas contains about 70% of methane, sometimes called marsh gas, which causes the will-o'-the-wisp on bogland. It has more heating value than coal gas. You can see it burning in this incandescent mantle. Inside the tanks, the sludge is held for about 3 weeks, and from it is produced 1.5 million cubic feet of gas every day. This gas provides power and heat for the whole of Mogden's requirements. Used in boilers, it heats these buildings. It's used in cylinders to drive all the lorries and vans and cars needed in the running of the organization. In the vast powerhouse, engines turn the gas into power. Power which drives compressors supplying the air for the aeration tanks. In this way, the sewage is made to provide power to purify itself. Other engines drive large dynamos which produce electricity for the whole works. The electric crane is worked by it. All the pumping stations use this power. And the outside machines used in treating the sewage are kept running by this self-produced electricity. It works the lifts, and even the clocks, and the floor polishers, and it provides light for the whole estate. All this from sludge. The gas generated at Mogden from this waste product would serve the gas requirements of a town of 100,000 people. And what is left of the sludge after this process is still of value. By the power provided by itself, the sludge is finally pumped away through pipes 7 miles long to Perry Oaks. There it remains in tanks until it can be discharged onto drying beds. Spread out in large areas, the sludge is left for a few months. It gradually dries into a substance not unlike peaty earth. It makes an excellent fertilizer, and local farmers buy many thousands of tons a year to spread on their fields to improve the crops. What might have been a source of danger and contamination goes back to nature, harmless and productive, through these revolutionary processes of modern times. And so the sewage from the houses and factories in every part of West Middlesex runs away through a network of sewers to Mogden, there to be cleansed of impurities before passing as clear water into the Thames. This great undertaking belongs to the ratepayers and is operated through their representatives. The sewers and works, which help to maintain the health and comfort of the residents of West Middlesex, cost over £5 million to construct and require a large sum to operate. But all this expenditure works out at less than twopence a week for each resident in the area. A small price to pay for a great service.
All of our wildlife depends upon clean water for existence. And this kind of fishing is successful only in clean water. Clean water is essential for livestock and for irrigation. It is also necessary for commercial fishing. Oyster. And salmon. And all types of freshwater fishing. Fish eggs need clean water to hatch. Fingerlings need clean water to grow into trout to challenge the sportsman's skill. From the beginning of time, our rivers, lakes, and the 7 seas have been arteries of transportation. Factory sites may be chosen because of the availability of sufficient clean water, a vital factor in many industrial processes. And most important of all, our natural waters are the major source of our drinking water. In fact, 75, almost invariably, man settled near to water. He needed water for his domestic use, for food production, for his industries, and for transportation. Being near water his communities dumped their waste matter, their sewage, into the streams for easy disposal, thus creating the serious problem of pollution. A problem which has grown increasingly serious as communities have increased in size. We pride ourselves on our high sanitary standards, yet we deliberately make open sewers of our waterways. The clean, clear waters that were once so friendly and useful become greasy and ill-smelling. Scum forms on the surface. Floating refuse lodges on shores filthy with layers of rotting wastes. Once attractive residential districts have declined in value. Bathing beaches and swimming holes are closed to the germs of waterborne diseases. Typhoid fever, cholera, dysentery, and other intestinal infections thrive in polluted water. These deadly sewage bacteria are frequently carried long distances by flowing streams, sometimes contaminating drinking water supplies and rendering them dangerous to public health. Remember that 3/4 of our communities take their water from lakes and streams. Livestock pastured near polluted water may become infected. Germ-infested shellfish taken from contaminated waters are a menace to health. Sewage, many a sportsman's paradise is threatened with destruction, or has already been destroyed by the pollution of our streams. Polluted waterways hinder shipping, befouling and rusting boats. Entire communities have suffered from hydrogen sulfide fumes from polluted water. These fumes are not only disagreeable, but are also destructive to the paint on buildings. Industrial plants needing a plentiful supply of clean water will not locate along polluted streams. All of these calamities are caused by the tremendous quantities of sewage and other wastes constantly poured into our inland and coastal waters, with its former size. And oysters more than doubled in price because of pollution. At one time, millions of pounds of salmon were taken each year from 28 streams along our North Atlantic seacoast. Today, pitifully few of these streams yield any of this valuable food and game fish. In numerous places along our coasts, sea bathers are forced to travel many miles to find waters not contaminated. In one West Coast area, an estimated 54 million additional miles are traveled each year by people whose home beaches are polluted. A beach resort on an eastern shore, which cost $5 million and gave pleasure to thousands of people, was made unfit for use as a resort because of pollution. The recreation and economic losses due to pollution affect the lives of every one of us. The United States Public Health Service says, pollution of our natural water costs the country more than $100 million annually exclusive of many important intangible losses. All of these losses can be avoided through sewage treatment, an economical and effective process. Raw sewage, the collected wastes of a community, is channeled into the plant. Modern, efficient treatment plants, employing processes developed by sanitary and consulting engineers and equipment manufacturers, remove the polluting materials. The exact process used depends upon various factors, but the final product is in all cases the same. Clear water which can be turned back into the stream without harmful effect. Complete sewage treatment consists of two major steps: primary treatment and secondary treatment. The primary treatment includes the mechanical removal of solids which will settle out. It starts when the raw sewage enters the plant. In a typical plant, the sewage first flows through a mechanically cleaned bar screen which removes any coarse material that might damage the pumps or other equipment. The sewage then passes slowly through the grit removal basin, allowing the grit to settle out. From here, the sewage is lifted into a settling tank by pumps. The pumps are usually driven by electric motors such as these. Settling tanks vary in design, but the purpose is the same. Here, the speed of flow is greatly reduced to let the suspended organic matter settle to the bottom. Sometimes chemicals are added to help sedimentation. The settled matter, called sludge, is pumped to an enclosed and heated digestion tank. In the digestion tank, helpful bacteria which thrive without oxygen reduce the sludge to a useful humus-like residue. This process generates a gas that may be burned to furnish heat or power to operate parts of the system. After digestion, the sludge is dried or dewatered. This may be done by spreading it on sand beds to dry by evaporation. It may be more rapidly dried by mechanical processes. The dried sludge is useful as fertilizer, but unless heat treated, it should not be used on vegetables that are eaten raw. These steps then comprise primary treatment: screening, grit settling, settling of solids, sludge digestion, sludge drying, and sometimes chlorination of the effluent. The secondary treatment includes the biological transformation of any organic matter remaining in the liquid that was drawn from the top of the primary settling tank. This liquid is treated in a filter which trickles it over rocks on which live bacteria that thrive in the presence of oxygen. This may be done by any of several filtering methods which allow these oxygen-loving bacteria to oxidize the remaining organic matter and coagulate the solid matter into clumps which will settle out. Or it may be done by the activated sludge process, in which large quantities of air are blown through the liquid to which a bacteria culture has been added. The effluent from any of these processes may be drawn off into a tank for final settling. The remaining liquid, after any further necessary filtering or chlorination, is a clean effluent which can be discharged into a stream or body of water with almost all the dangers of pollution removed. Of course, safe for drinking, surface water from any source must be treated further in a modern water supply system. This successful transformation of raw sewage into clear, clean effluent is accomplished in specially built, especially equipped, and efficiently operated plants that have been developed largely within the past 50 years. There were only 60 such plants in 1900. By 1910, there were 300. Their numbers grew until by 1945, there were over 6,000 plants in use. But at the same time, thousands of other communities were installing sewers for the first time and turning their untreated wastes into our waterways. So today, our public health service officials estimate that there is a pressing need now for more than 10,000 new plants. And in addition, a large number of the existing plants are inadequate. This great need for efficient sewage treatment exists in almost every community. So long as we ignore this need, pollution will menace health, rob us of food, reduce property values, destroy wildlife, and add greatly to the difficulty and cost of providing safe city water supplies. Adequate treatment of sewage will eliminate these dangers, handicaps, and losses from pollution. Cooperative planning by the communities in your area will be required to coordinate and develop the broad programs needed for adequate sewage treatment. Our water needed to satisfy the nation's present and future needs, will furnish sound public works programs, and will provide employment for thousands of workers. Authorities estimate that on a national basis, the saving of the $100 million lost annually as a result of pollution would very nearly pay the entire cost of the construction program. The result will be the return of our inland and coastal waters to their original natural state, so that they may again be unhampered in performing their natural functions in our industries, in supplying our food, providing recreational opportunities near home, the conservation of our fish and game, and caring for our welfare in many different ways. Then the voice of the waters, the surging surf, combing breakers, the tumbling, gleaming cascades of mountain torrents, the placid, deep-flowing rivers, the gentle lapping at the shores of inland lakes, will again find vibrant, joyous expression in the merry bubbling of the brook, and renew the age-old prophecy murmured by its clean, clear water. I wind about, and in and out, with here a blossom sailing, and here and there a lusty trout, and here and there a grayling. and draw them all along and flow to join the brimming river. For men may come and men may go, but I go on forever.
When Mrs. Jones turns on her kitchen tap for the first time in the morning, she starts a flow of water into the house, which with brief intervals continues all day. She can see and control the water coming in. But where does it all go when it leaves the house? Where does the washing up water go when the bowl is emptied? The amount of water it takes in a week to keep one small boy's hands clean would probably float a battleship, and it seems that the bath is hardly empty before someone's filling it again. Where does all the water go when it swirls around and disappears? Soap and water rub out mud and dirt from clothes. The clothes become clean, but the water is often left very dirty. The washing up that goes on in the house is magnified to huge proportions in places such as multiple dairies. Just as Mrs. Jones's washing up water goes down the sink, so the water that washed 10,000 bottles goes down the dairy drain. And so it is with industry in general. Trade waste presents a stern problem for the public authority in charge of main drainage, for some of it is harmful and dangerous. From breweries, engineering works, chemical and dyeing works, the waste from the various industrial processes runs away down the factory drain. These flows from factories are larger than those from houses, but they all find their way into the same sewers. When any building is erected, whether to live in or to work in, drains are laid leading to the sewer under the road. Some sewers lie near the surface. Others are very deep in the earth. They run across country and under city streets, man-made rivers in tunnels of brick and concrete. Small local sewers flow into larger ones, and the waste waters of a whole district move as tributaries towards one great stream. Down it goes through the convenient hole in the sink. But where does it go? It's a simple thing to throw away the dirty water from cleaning floors, or to pull the lavatory chain and see the water cascading down. But where are the waters rushing? Before the development of modern drainage during the past century, sanitation was primitive. Today it's taken for granted. The Jones family and all the people who live in their street can empty their sinks as simply and easily as they switch on the electric light. The maintenance of public health depends upon the efficient removal of this sewage, not only from houses, but from all the public lavatories, shops and hospitals in the community. As in natural rivers, the streams vary in appearance and rate of flow. At times of great activity, the sewage runs deeper and dirtier. On Mondays, there is the soapy evidence of wash day. From the first small drain down to sewers larger than a tube railway, like this one, the unwanted wastes of the world above the street are carried safely away. The very existence of modern cities depends upon drainage. After the first, and areas that were largely rural became industrial and residential. In the county of Middlesex, the local authorities were faced with many problems. It became increasingly